Welcome to Saxon Math, Course 3, Lesson 109, Starred Problems. Now, our first starred problem in Lesson 109 is problem number 1. Now, problem number 1 says a random survey of 400 out of 20,000 likely voters found that the ballot measure was favored by 220 people. Based on the results, predict the number of people who vote in favor of the ballot measure. Well, favored by 220 people means that 220 people liked the ballot. If we're hoping that this random survey of 400 correlates exactly, we can say that 220 over 400, the amount who liked the ballot over the amount who we measured, will vote in the same ratio. In other words, would be proportional. So we need to find a way to get from 400 to 20,000. That way is multiplication. We're going to multiply by 50. If we do 220 times 50, we'll get 11,000. And that's how many we would estimate would vote for the ballot based on this random survey. Star problem number 2 says if 2 people can set up all the chairs in 12 minutes, how long will it take 3 people and 4 people? And are these variables in this situation directly or inversely related? Well, I'll tell you already, if more people start setting up chairs, it will take less time, meaning that if one variable goes up, the other one will go down. That means they're inversely related. Now, it's important that we discuss that they're inversely related first, because inversely related variations have a formula of variable times variable equals a constant. So we're going to multiply the two variables we get, people and time, 2 times 12, and get 24 as the constant, meaning that no matter how many people we have, the people times the time will be 24. Now, for 3 people, we'll divide by 3 and get t equals 8. For 4 people, we'll divide by 4 and find that the time equals 6. Seeing that as we increase the number of people, we decrease the amount of time it would take to set up the chairs. Question number 3 in the star problems says when Fred started the novel, he read an average of 35 pages a day for 4 days. To finish the book, he averaged 42 pages a day for 3 days. What was the average number of pages he read per day over the whole 7 days? Well, 35 times 4 would be 140, and 42 times 3 is 132. If we add 140 and 132, we would get 272. Now, if we're trying to divide 272 by 7, 7 will go into 27 3 times, leaving a remainder of 42. 42 divided by 7 is 6, meaning that he read an average of 36 pages each day. Oh, I'm sorry. This should be 36. 136, 276, and 276 minus 21 is going to be 38 pages a day. The next star problem is question number 4. Find the perimeter of a room that is 12 foot 9 inches long and 11 feet 4 inches wide. So you're going to add up the length twice and the width twice. So 12 foot 9 inches plus 12 foot 9 inches plus 11 foot 4 inches plus 11 foot 4 inches. Start by adding the inches. 9 plus 9 is 18 plus 4 is 22 plus 4 is 26. 26 inches is 2 feet and 2 inches. So we're going to put 2 inches here, and we're going to put 2 feet up there. Now, 2 plus 12 is 14, plus 12 is 26, plus 11 is 37, plus 11 is 48. So we'll get 48 feet, 2 inches. Now, our next hard problem is question number 5. It's a two-part question. Part A is asking us to factor. Part B is asking us to expand. When we factor, we look for what they have in common. Now, we can see already they both have an x. This has x squared, which is x times x, and this just has 1x. So we'll take 1x out. And then we can see that 6 and 9 both are divisible by 3. Now, if we divide 6 by 3, we'd get 2. If we divide x squared by x, we'd get x. If we divide negative 9 by 3, we'd get minus 3. And if we divide x by x, we get 1. So we would get 3x, parentheses, 2x minus 3. When we're expanding, we do the number outside the parentheses distributed into both terms. So negative 2x times x is negative 2x squared, because x times x is x squared. And negative 2x times negative 3 is positive, because we have a negative and a negative. 2 times 3 is 6. There's no x, so it's 6x. Our next star problem is question number 8. Question number 8 says the difference between length and width of a rectangle is 3. The perimeter is 10 inches. Find the length and width by graphing. So we have a system of equations here where x minus y equals 3 and 2x plus 2y equals 10. Now, if I put both of those into a table, if I plug in 0 for x, I'd have negative y equals 3, so that means y is negative 3. If I plug in 0 for y, I'd get x equals 3, so x equals 3. For 2x plus 2y equals 10, if x is 0, 2 times 0 is 0, so 2y equals 10. If 2 times y equals 10, y equals 5. If I plug in a 0 for y, 2 times x plus 2 times 0 equals 10. 2 times 0 is 0, and 2x equals 10. 2x and 10 divided by 2 would give us x equals 5. So now we have the points 0, negative 3, and 3, 0, which we'll graph real quick. Remember, always use a straight edge when you're graphing, especially when you're solving systems of equations. It's not something that you can do when you're estimating. You can't sketch out a graph to solve system of equations. And then we have 5, 0, and 0, 5. And you got to make sure that these are nice and exact. So you can get that good intersection right here at 4, 1. And 4 minus 1 is 3, and 4 times 2 plus 1 times 2 is 10. Now, question 9, 10, and 11 are all starred problems, and they use these similar pyramids. Now, we can see that one is a smaller one, has a base that is a 3 by 3 square with a height of 2. There's a larger one, which is a 6 by 6 square and a height of 4. Now, I've broken this one in because we're going to need to find the slant height in one of the problems. And remember that the slant height is found by making a triangle with the one base as half of the base here, so half of 6 is 3, and a height that is the height of the pyramid, so 4. Now, question 9 says find the volume of the larger pyramid. The volume is 1/3 times the base area times the height. Base area would be 6 times 6, and the height is 4. Apparently my Siri is chiming in and telling me that 6 times 6 is 36. That's correct, but I was going to do 1/3 of 6 is 2. And then times 6 times 4. And 2 times 6 is 12, times 4 is 48. And that would be cubic inches. Now, part B says, draw a net of the large pyramid. Now, the net of the large pyramid would look like this, where we have a base of 6. We don't have our slant height yet, so we can't note that, but you can see that it's got its 4 sides that are 6, 6, 6, 6, and then it has triangles popping out of it. Now, question 10 says, use the Pythagorean theorem to find the slant height. Remember that we found that triangle with a base of 3 as half of the base right here. So 3 squared plus 4 squared will equal our slant height squared. Now 3 squared is 9, 4 squared is 16, and 16 plus 9 is 25. The square root of 25 and the square root of c will give us 5 equals c. Now, using that slant height, we're going to find the lateral area of the pyramid. Remember that lateral area is 1/2 times the perimeter times the slant height. Now, if we've got a perimeter going around this base, 6, 6, 6, and 6 make 24. And the slant height we found was 5. Half of 24 is 12. 12 times 5 is 60. And this would be square inches. Now, 11 asks us to find the scale factor from the smaller pyramid to the larger pyramid. So we're going to take the larger pyramid and put it over the smaller pyramid. I'm going to use their heights. So I'm going to put 4, which is the height of the larger pyramid, over 2, the height of the smaller pyramid, and 4 divided by 2 is 2. We're then asked to find the ratio of the surface area from larger to smaller. Ratio of the areas is always the scale factor squared. So 2 squared, which is 4. So 4 to 1, larger to smaller. Now, the ratio of the volumes from larger to smaller, we're going to know that the ratio of volume is always the scale factor cubed. So 2 to the power of 3 is 8. And so the ratio from larger to smaller is 8 to 1. And you can see that now. Sorry I didn't bring that down sooner. I'm going to give you a second to copy that one down. Remember that if you're watching this video before 1 o'clock today, if you have any questions, you can come through and ask me about them during the Zoom meeting today at 1 o'clock to 3 o'clock. Now, our next star problem is question 13. Question 13 says Sonia has a $4,500 balance on her credit card. The finance charge is 2% per month. If she makes only the minimum payment of $100 this month, how much of her payment will pay interest, and how much will be used to reduce the balance she owes? Well, first off, we should find out what her interest is. So 2 times 0 is 0, 2 times 0 is 0, 2 times 5 is 10, 2 times 4 is 8, plus 1 is 9. And then there are 2 digits after the decimal place. So that means her interest is going to be $90. And then if her minimum payment is $100, if we subtract the interest from the minimum payment, that means she's only going to be paying $10 to reduce the payment, to reduce her balance. And you can see, even with small interest rates, once you start getting into large credit card debt, the minimum payment's not going to be reducing the amount you owe, it's only going to be paying the bank's interest. Our last star problem is question number 25, and it's drawing an isometric view of the solid figure that has these side views. Now, my recommendation when you've got a question like this is always start with a diagonal drawing of the top-down view. Now, the top view has 1, 2, 3 squares. So I'm going to draw 3 squares. And then 2 squares below it. And I'm doing this in pencil because you're going to want to be able to erase. Now, looking at it, we can then look at the right-hand view. If we imagine that these boxes were viewed, remember, because this is the top. If we imagine that we're viewing from the right now we have the 1, 2, 3 of this, and that means we need to have a upright over here, meaning that at the very least, somewhere here, there needs to be an extra layer of boxes added up here. And then we're going to look at the front view, where we have the 2 bottom, and notice there are 2 on the bottom right here, and there need to be 2 on the top, so we can add those in right on top here. And as we add them in, we've got a shape which, if you look from the front has 1, 2, 3, 4 faces, which we can see would be these faces here. The top has 5 faces, which we can see right here. And the right-hand side has 4 faces, which we can see right here. And you can see how each of those sides plays out. Now, I always like to go top, then side, then front. I find that that makes it the easiest to draw out the shape. If you're going from the sides to the shape. If you're going from the shape to the sides, it's pretty easy to just come up with some color coordinations and then get that picture drawn. But if you're going from the separate sides to the three-dimensional shape, I recommend starting with the top, then going to the right, then the front. Alright, that's the final question on the homework and the final starred problem, so make sure you complete the rest of the problems, stay safe, stay inside, and wash your hands.